There's this silent vandal all around us, an invisible force that's slowly, methodically eating away at our world. It leaves its mark on everything, from ancient monuments to the very air we're breathing right now. So let's start an investigation and unmask this culprit.
Okay, picture this. You're standing in front of this gorgeous stone statue, right? Carved centuries ago. But something's wrong. Instead of sharp, clear features, its face is blurred, almost dissolving away, like it's been hit by some strange disease. This isn't a sci-fi movie. This is a real-life crime scene, and it's happening everywhere. So the big question is, what in the world is doing this? And I want to be clear, we're not just talking about the vague idea of pollution. No, we're talking about an active, aggressive force that is literally deconstructing our world, piece by piece.
All right, every good investigation starts with a list of suspects. So first things first, let's identify the main players here, the specific pollutants that are causing all this damage. Suspect number 1, sulfur oxides, or SOx for short. These gases mostly come from burning fossil fuels that have sulfur in them, think coal and oil. Once they get up into the atmosphere, they turn wildly corrosive. These are the chemical specialists of the group. Next in the lineup, we've got nitrogen oxides, or NOx. These are super reactive gases that get created anytime fuel is burned at really high temperatures. And where do you find that? Well, the number one source is the exhaust pipe of your car. They're a constant presence in any city. And then there's lead. Yep, that toxic heavy metal. We've been punking this stuff into the air for a long time. Now, we've gotten a lot better since moving away from leaded gasoline, but it's still coming from industrial spots like smelters and refineries. So let's look at lead's rap sheet for a second. Sure, some of it is natural. It comes from volcanoes and even dust in the soil. But the overwhelming majority, that's on us. Get this. A staggering 70 to 80% of the lead ever added to our atmosphere came from just one thing: leaded gasoline. It's pretty wild. And our final key suspect is something called particulate matter, or PM. Now, this isn't just one chemical. It's this messy cocktail of incredibly small solid bits and liquid droplets just hanging out in the air. Think of these as the tiny grunts of the operation, causing damage just by being there. Okay, so we've got our suspects lined up. Now for the really interesting part. Let's dig into their modus operandi, the exact methods they use to pull off these acts of destruction. So, they basically have two main ways of working. First, there's the direct chemical attack. This is like a frontal assault. A pollutant just lands on a surface and immediately starts dissolving it. Then there's the indirect chemical attack, which is way more sneaky. It's like sabotage. The pollutant soaks into the material first and then starts a destructive chemical reaction from the inside out. Acid rain is the perfect example of that direct attack. It's a simple, brutal process. First, SOx and NOx in the air mix to form stuff like sulfuric acid. Then, when it rains, that acid falls on stone like limestone or marble. The acid literally dissolves the stone, turning it into a new, weak material that just crumbles and washes away. And just like that, a statue's face is gone. Now for a more complex method, electrochemical corrosion. This is actually fascinating, in a destructive kind of way. When pollutants land on metal, they create these tiny little physical and chemical imbalances on the surface. These spots act just like the plus and minus ends of a battery, so you effectively get millions of microscopic batteries all over the metal, powering a process that just eats it away. But here's the thing. These vandals rarely act alone. Like any good criminal crew, they have accomplices, environmental factors that help them out, creating the perfect crime scene and speeding up the damage like crazy. And their number one partner in crime? Moisture. It's a total game changer. Just look at this chart. When the air is dry, you can have a lot of pollution and you'll see minimal corrosion. But as soon as that humidity climbs up past 70%, boom, the corrosion rate just skyrockets. Moisture is the fuel for their fire. Of course, temperature and sunlight are in on the gig too. It's simple, really. Higher temperatures make chemical reactions happen faster, so the damage accelerates. And sunlight? Well, its UV radiation provides the energy to create new pollutants like ozone, while also directly attacking things like paint and rubber, making them fade and crack. So we've seen what this does to stone and metal, and that's bad enough. But honestly, that's just property damage.
Now let's shift focus to the true cost of all this, the absolutely devastating impact it has on living things, including every single one of us.
Let's just start with plants. Ozone literally injures the tissue of a leaf. Nitrogen dioxide acts like a poison that stunts a plant's growth. And sulfur dioxide? It's especially nasty. It causes chlorosis, which is when leaves turn yellow and can't photosynthesize, and even necrosis, which is just straight up tissue death.
And hey, remember that particulate matter? Well, it doesn't just damage surfaces, it literally blots out the world. The only difference between that crystal clear view on the left and that soupy, hazy mess on the right is the amount of those tiny particles in the air. This is what we're walking through. This is what we're breathing.
And that brings us to the most critical cost of all, our health. And we're not talking about maybe getting sick years from now. These are the immediate, acute effects. Carbon monoxide literally robs your blood of oxygen. Lead can cause brain damage. Nitrogen dioxide makes you cough and can fill your lungs with fluid. And those photochemical oxidants, smog basically, are what cause that burning eye feeling and so many respiratory issues. This is incredibly serious stuff.
And to really understand why particulate matter is so dangerous, you just have to look at this one number, 4 micrometers. That's the size of what scientists call a respirable particle. It is so ridiculously small that it slips past all of your body's natural defenses, your nose, your throat, and lodges itself deep down in your lungs, right where your body is trying to get oxygen.
Now, if you think this all sounds a bit theoretical, it is absolutely not. We have seen what happens when all these elements come together. The Great Smog of London in 1952 was the perfect storm. You had all our suspects, all their accomplices, the pollution, the moisture, stagnant air, all working together. The result was a lethal combination that caused thousands upon thousands of deaths. So we come full circle. We can see the evidence of this silent vandal carved right into the faces of our statues, tarnishing our buildings. The damage is obvious. But the real question, the one we have to ask ourselves, is this. What is the invisible toll this is taking on our health, on our environment, and on our entire future?